Hello, good morning, everyone.
Good morning.
Okay, so today's topic will discuss the component failure prediction, component failure analysis. It's related to automobile industry, manufacturing industry, wherever they are using any kind of continuous process. Okay, so this particular concepts, whatever concept we will learn, it will be generic concept. You can apply the same thing on different industries also. Only the you have to take care the related technical terms, technical mathematical calculations, technical complexities, all those things only. So it's a basic problem in all the industries. So in the real world scenario, this kind of prediction, they are always expecting from AI, machine learning experts that suppose this is a car in a car manufacturing company, they are interested to know that a particular piston, ball bearing, okay, and nowadays the lots of cars are highly electronics also, software based mechanism are there, but many things you can predict in advance also, even in the car manufacturing companies. Yes, with number of kilometers and number of different areas we have traveled, use the car in different location, these things will be definitely change. Suppose it's not only based on the how many kilometer you have used the particular car. If you are using the car in the hilly area, definitely the component and its life cycle will be changed. Similar things if you are using this car in sea, near sea areas where lots of humidities are there, rusting will be very high. So these all things depends on the life cycle of the components. So when you real in the real world scenario, when we work on such kind of problem statement to predict the life of the car, life of the particular component of a car or any device, so many factors we have to take care, like as whether it is a 2 cycle or 4 cycle. Okay, it's a what is the source of energy, it's a petrol car, diesel car, CNG car. Okay, so these lots of things are required to we have to take care. So one of my friend who had worked on this particular concepts some 6 7 years before, they have developed one component failure prediction, and it was purely related to the commercial car, and they sold their software to some German company. They have the company was based in Bangalore. So after some 3 or 4 years of operations, finally they designed a very good model, and they sold that model to a German company at very high price. So these type of topics are really very important, but the important factor here is uh, the data set. Getting a data set is really difficult, but yes, but whatever concept is there, you can apply the same concept on different industry, like as automotive industry, elevator manufacturing company, also lift, they are manufacturing the lifts. Okay, or any kind of automation industry. So they always require the prediction, because the if you are able to predict a particular component failure in advance, so a lots of time can be saved. And suppose it is related to some automobile, lift, or aeroplane, then it's definitely will help to enhance the security and all those things also. Okay, so this topics is really very important. You can with little modification, whatever experience you have, suppose you are working in any kind of manufacturing industry or any kind of capital equipment sales industry, any kind of, so you can modify. Yes, you got some idea of this, of the component failure prediction also. Okay, so in the real world scenario, data scientists often start an analysis with a simple and easy to implement model, such as regression, classification. So basically our main purpose is to do some kind of prediction. And suppose the same concept if you want to apply on any car manufacturing company, elevators, or any kind of uh, transportation related company, even in medical sectors also, the some medical devices are really so important, like as ventilator. So usually ventilators are connected with highly critical patient in the intensive care room or in the operation theater. So ventilator is continuously helping the patient in breathe in, breathe out. And assume that you have not properly checked the ventilator, it is not properly maintained, and you have no idea about the which particular component's life cycle has already completed. And assume at the midnight your ventilator will start giving some wrong information, it start malfunctioning. So in 5 minutes or 5 minutes of time, the patient can be die. So definitely, if you are talking about any kind of critical equipment like a ventilator also, so a prediction is very important. The different components of the ventilator, just this particular life cycle has completed. So better in advance if you will change it. So it will enhance the particular brand image, as well as it help a lot to the healthcare sector also to take better care of the patients. So any industry you choose, this particular topic you can use component failure prediction. Okay, so this is related to this particular data set related to our automotive industry and manufacturing industry. So basically, component failure analysis is the process of analysis the component data or the component itself to determine the reason for degraded performance or catastrophic failure of the component, either during the component manufacturing, performance testing, during the incoming inspection, or after delivering the customer at the final application also. So all any of the scenario. So it's it definitely the components of the data set or in attribute of the data set will be changed, but the concept is same. But the concept is same. We have to predict in advance what is the reason of failure, all those things. So here this particular data set, we have few attributes are there. One is the type, means what the targeted, suppose we are working on a particular component. So what is the type of the component? It's the medium quality, high quality, or low quality. Because whenever you manufacture any of the device, any of the item, so naturally there are many components are there, many parts are there in the device. So sometimes we compromise some of the parts at price also, because you cannot keep all the things very expensive inside a device, otherwise the price of the device will be finally very high. So many times we will found that yes, this particular component we can keep even low price also, some components you can keep high price also, some component you can keep medium price also. So one column is there, the type, low, medium, and high. So we will also see here what is the impact of failure if the type is low, if the type is medium, type is high. We will see here really a high quality having very low failure, or there is no much difference in the low quality, medium quality, or high quality. Low quality, medium, high means there is a difference in the price. There is a difference in the price. So this is the one column we have. Second column is the air temperature. It's generated using the random walk process. So randomly it has selected the air temperature, process temperature also. Rotational speed is also one of the important factor here. Rotational speed. So if you are anyone from the manufacturing background, they will must aware that the rotational speed and torque. Rotational speed is nothing but the rate of rotation of an object. Okay, it's the RPM, rotation per minute, and it's calculated from the power of 2860 watt. It's already given, overlaid with a normally distributed noise also. And torque is also one of the component here. So torque value is in Newton meter, and it has been distributed around 40 Newton meter. Okay, so torque is the rotational equivalence. Actually, What is torque? Torque is a rotational equivalence of linear force that cause a object to rotate. It helps us an object to rotate. Okay, so these all are the components. Rotational speed is there, torque is also there, and we will also see the relationship between the torque, rotational speed, along with the. Just please hold on 1 minute, no? Yes. So we will see the what is the relationship between torque, rotational speed, with respect to the failure, with respect to the component failure also. That also we'll see. And tool wear is the also quality variant, high tool wear, low tool wear, medium tool wear, these all things. In this data set, the interesting thing is that we have two target variables. One column is the name is the target. Target means there is a failure, no failure. Means component is yes, no. So it's a binary classification. And we have one another column. We have one another column that is the failure type. So failure type is the type of failure. And here we will find the different kind of failures, like as failure due to heat dissipation, failure due to high torque. Okay, so many options are there in the failure. Power failure is there, tool wear failure is there, overstrain failure is there because of strain stress failures. So as per the different industry, you will find some different kind of this thing also. So it is you can say a basic introduction if you are interested in any kind of pure engineering project. Assume you are interested to work in oil and gas industry. So definitely the main purpose of working on oil and gas industry is not to find the stock price prediction of oil and gas industry. No. If you are working on oil and gas industry, that means you want to know, because there are lots of accident in oil and gas industry, lots of accident. So you want to find out the reason behind the accident. All those things you want to calculate. If you want to work on any kind of cement manufacturing industry, again you have to take care what is the reason, the quality of the cement manufacturing, what are the most important factors. Okay. So whatever engineering industry you will choose, some technical terms will be involved there. Okay, so here are very basic terms are there. So failure types is multi-class classification. We have different types of failure: heat dissipation failure, power failure, overstrain failure, tool wear failure. These all many factors. You can Google also. You can find the what is the meaning of this different failure and what is the reason of this. So it's not very complicated, but yes, your interest is required in this particular domain. Then only you can. So heat dissipation, basically it's a overheating. It's because of whatever the waste heat are there, they are not properly drained out. Everything will work in the mechanical process. It generates heat. If the particular waste heat, whatever heat has been created, either it will be consumed as a energy, so it's all fine. But if it is not consumed, it's the waste heat. If it is not properly drained out, the overheating may be caused. Okay, and this is also one of the reasons of any kind of failure, overheating. So these all things we will see. And now the interesting thing, we have two target variable. So can anyone tell how to solve this particular problem in our data set? Suppose we have two targets variable. So how to predict these two different columns? Yes, Mohammed Fakhruddin.
Oh, 1 second. So using the algorithms, we can predict the first one too. For multi-class classification also, we can use predict using algorithms and target for binary classification also.
Yeah, we will make the prediction, but what approach we have to follow here? Because most of the data set, as you have worked, we have all the independent variable and just one dependent variable. So we have we can keep all this as X, and this
Yes.
particular column we have selected as Y, and then we will whatever training testing we can create. But here the problem is we have two
Yes, sir.
columns are there.
Uh-huh.
Yes. Yes, Nina, do we have any idea? Nina Matthew?
No, sir.
Okay, no problem.
I think we have to use a binary classification.
No, we have two classes. Na? One is the one target variable is the binary classification, and
Yeah.
another target variable is the failure type is the multi-class classification.
Yes.
So whenever you have this kind of problem, na, we will work
Yes.
it individually. So no, naturally our X is common. All these input variables are common. Independent variables are common. But we have in one case number one, we will keep all these independent variable and we'll keep the one target variable. This assume it is y1 and it is y2. Okay. So in one case we will just keep y1 and we'll solve it. We'll predict. In another case, again we will have x and just we'll take here y2. Okay. In this case, we cannot keep y2 here in any condition. We cannot consider it as a independent variable in the prediction of y1. And similarly, in this case, we cannot keep this y1 as a independent variable also. No. Both are separately we have to calculate. But yes, in the deep learning, in the TensorFlow, when you learn, there is one option. There is one, you have to write some kind of program. In this case, you can predict two target variable. You can keep two target variable together and you can make the prediction. But I hope no trainer will teach this particular concept because this is a little bit complicated. So in this TensorFlow, there is option are there. We can predict two target variables. In the output, you will get the two. But in this supervised machine learning and all these things, whatever we have learned, we have to do it individually.
Okay.
So are you talking about functional API?
Functionality of?
Are you talking about functional API? Like at a time we can predict two.
Yes, we can, but in the TensorFlow, some options are there. When you learn this particular
Okay.
neural networking operation, so we can we have at the output we have the options to get the two output, two or three multiple output you can get at the multiple output, multiple target variable. Okay, in the TensorFlow deep learning. So
Okay.
let's start the notebook and let's start working on this data set and see how it works. So this particular PDF also I have shared, and let's start the notebook and we will work together. So people had not joined in the project session because they think that it is not required, or the reality that many people today are finding in YouTubes and everywhere now chat GPT has come, then there is no use of data scientists. So few students who are always finding some kind of excuses, so they can inform their parents also, look, now the chat GPT has come, so this is there no use of learning all these things because everything chat GPT will do. But just a simple example, very funny example you can take with your with that you have also faced. Have you joined this course with the help any robotic approaches they have followed? Any robot has explained you and you joined this course? No, because of the continuous follow by the salesperson, you have joined this course. So the same thing will be happen even after the any things will come. You cannot ignore the human intelligence, their effort, their consistency. Okay. So I used to share some always little articles on my WhatsApp, what's in say profile, or you can say jo every day it's available for 24 hours. So I usually every day I put some new articles. Okay. So this you can,
Yes,
if you
yesterday
found,
only you put, I think,
yes. So
data scientist
don't,
in ChatGPT.
right, sir. So don't create any kind of fear factor. These things will come and go, but yes, there is no replacement of human intelligence, their domain expertise. So as I told in the last class also, there nowadays the most of the European and US based companies, these things I'm not just informing you by reading somewhere on Google, because many of my friends, many of my counterpartners are in US and European countries. I'm every day I'm finding the differences, I'm finding the changes. So almost all the companies are looking for good decision makers who can help them to take the correct decision, because of the lots of competition, because of the, suppose you are doing any kind of business, you have limited resources, you have limited fund. Okay. So if you are finding a very correct person who can guide you, yes, this decision is correct, this is not correct, here the chances of uh, failure is less. So these kind of characteristics are looking, they are always looking for in their senior employees. I'm not asking the very front level employee. Okay, but definitely in the middle management or upper management, these characteristics they required, along with data scientist skill, they required psychological skill, psychology, as well as managerial skill. These all things cannot be replaced by our chat gpt or AI. So definitely a human intervention is must. So don't, no need to worry. If you are really good, if you are working hard and you are intelligent, so definitely you will find a good opportunity as a data scientist, data analyst. Yes, please share the data set again. Some of your friend is asking. Okay, so let's apply here. Let's read the particular file. Uh, your real learning will start when you join some company. Okay, this is the hardcore reality. Your real learning will start when you join a company, when you start working on some assignment or project. Because many of my students who has joined some companies, someone is working in Accenture, some stock prediction company also, even though their syllabus is not completed. So there is some luck factor also, and also the reason that at the right time you should be at the right place at the right time. This is also one of the factor, and networking play a very, very important role for getting a good job. Networking means, suppose someone has given you reference about a opening in a company, your friends, even virtual friends also. So that's why be in contact with on social media like as LinkedIn. If you are finding someone is working in some company, you can ask some questions, some queries. Definitely most of the people are good people, they will help. So just import the basic library, import PD. So similar kind of project, at least we should do some 20-30, because every this problem statement will teach you something new. And if you have, we will done, because these projects are, we are just completing in 4 or 5 hours. Na? So if you will do some 45, 40, 50 number of projects, and don't repeat the same topic again and again, there is no use. Always pick a new topic. Okay, so after reading this, let's read the data equal to pd.read_csv, and this file name is component failure prediction.csv. Then we can make the copy of this. Df is equal to data dot copy df dot head. And then we can check this is the target and failure type. These are the two dependent variable. So let's check what are the different classes are there. So df target dot value counts. So it's not a, yeah, it's really a highly imbalanced data set. Normal is equal to true. One class is 96%, another class is just 3%. Right? And the same thing we can see here, failure type. Failure type, there is a space, there is not this thing. So we have 1, 2, 3, 4, 5, 6 categories. So in the failure type, we have no failure, heat dissipation failure, power failure, overstrain failure, tool wear failure. Okay, so power failure is naturally means we are not finding the power supply. Heat dissipation failure, we are not able to properly utilize the extra whatever the energy or heat has been generated. Random failure, they are not aware what is the reason. What is the reason, they are not aware. So these all things are there. And tool wear failure is because of the, you can consider as because of the some low quality. Okay, and this all overstrain failure is also related to, you can consider the because of the high torque. Random failures, you can also can consider overstrain because of the high strain stress on the particular components. These are the main reasons are there. So we will see 0 means no failure, 1 means failure. So if you see here, df 50 also. So 0, no failure, everywhere we are finding, no problem. And also we can find in the tail also. One is the power failure, they are indicating. 0 is the no failure. Okay. So no problem. So these are the main columns we have. And let's see what are the data type. So df dot info. So these are the basic. One is the ID is there that we require. We don't require in the prediction. UDI, product ID. These all things are not required basically. UDI. And type is the object type. Be natural. We have 3 types. You can also see what are these 3 types. So df one column is type. So basically we have 3 types of components: low price, low quality, medium, and high. So 60% is approximately low price. This is the object variable. So categorical is their type, and all are float integer, no problem. And also failure type we have checked. So first of all, we don't require these 2 columns. UDI is there, na? UDI. So let make this UDI and product ID. This will not help us any kind of prediction. So let's drop these 2 columns first, then we will see other things. So as the ID column has no impact, so let's drop it. So I'm just writing a new variable name. df1 is equal to df dot drop. One is the UDI and another one is the product ID. Okay, all fine. Now we can check here what are the different type of failure. Is there any mismatch or not? Because we have 2 columns here. In one column it's indicating yes, it is a failure, no failure, and we want to see here in the failure type. So we just want to see whether if it is saying no failure, so everywhere it should be no failure. If it is a failure, then everywhere it should be either any kind of failure, because these 2 are different target variables, and there should not be any kind of contradictory between these 2. There should not be any kind of contradictory between these 2. So let's apply. So let's calculate the failure components and the reason of failure, or to find the, let's check if there is any contradictory between the 2 target variable. So this is always required whenever when we have 2 target variable. We always check, is there any contradictory between the target variable or not. Someone is saying something, someone is saying something. It's not a good thing. Okay, because it will not help us in good prediction. So df failure. Just I've created a variable name df1 target equal to 1. I am just keeping those observations where there is a failure. Okay, so df failure dot head, we will have only those observations where the target variable is 1. Okay, so here we are finding failure type is equal to power failure, basic things we are finding. If it is failure, so let's see. If it is 1, let's see what are the different value counts. If it is a failure, what amount of power failures are there, what amount of tool wear failures are there. So, and by doing this process, we can also find if there are any contradictory or not. Let's see it. So df. So always remember, whenever you have two target variable, you must check the contradictory between the, if any contradictory between the two target variable. Two target variable, suppose one is saying yes, we should do this thing, and you have another target variable also that is also helping you to take the decision. So we just check in any of the row or observation, these two fellows having some kind of difference of opinion or not. That's we want to see. So df failure type. So df failure is this particular variable, this data set where all these values, target value is 1, and we are finding the value count of this column, failure type. Value counts. So are you finding anything which seems to be some kind of contradictory? Yes. Arnav Kundu. Can you tell?
Yes, so there is a contradiction. If you see, like in the target variable and in the failure
Yes.
type, 0 is 9661 occurrences, but in no failure, we have 9652.
Here I am talking about in this particular observation. We are working only on this part. We have I have selected target equal to 1. So this column is saying it's a failure. Now we are finding the reason of failure.
Oh, yeah, there is no failure in the when the target is 1, 9
Yes.
occurrences.
Yes. So this is the contradictory. This particular column is saying there is a failure. But what is the reason of failure? They are saying no failure. Means this is the some contradictory. This particular point. If you want to see what are those observations also, there is a contradictory. So if you want to see that particular column, that particular observation, are you connecting the dots or not? Please tell me, everyone, what I am saying. Let me ask someone. Gyan HBK. Gyan HBK.
Yes, sir.
Yes, Gyan. This is the. Are you connecting the dots? What I am saying? What are
Yes,
the
yes, sir.
contradictory? This
Yes, sir.
particular. Yes. Can you explain, please, again?
Actually, it since the target is here 1, so there should
Yes.
not have been this no failure here.
Correct. This is the
Those
contradictory.
9 observations should not have been there.
Correct. Okay. So this is the contradictory. Let's see what are the this. Let's explore the observation where there is contradictory. In contradictory between two target variables. into dependent variable. So whenever you work on any kind of data set where we have two dependent variable, you must check this thing. So df, because these kind of things they can ask in the interview. If you will say yes, so they will ask, okay, what was the steps, what steps you have taken. So df failure. Failure type is our column name, and equal to no failure. Okay, so these are the all the 9 observations where target is saying it's failure, but here it is no failure. So you can send this thing. Suppose you have done this thing, you can send this particular observations to your further examining committee, that what is the reason why there is this reason, either really these are the failure or not, it's all working fine. So they can cross check this thing, no problem. But as a data scientist, as we have found that this is a discrepancy in our data set, so let's drop those observations where there is a contradictory. But we must write this thing in the comment that we have observed this thing. It's required whenever you work on any kind of project, you should write in the comment, we find the contradictory in the these observations where the air temperature was this was this, rotational speed was this, torque 42 somewhere this also, and we found that the two target variable are having the contradictory this thing. You should write this thing. But let's drop this observation. Because we are not sure, we are not the specialist of this particular, we have no in detailed of the hard this domain knowledge, that's why there is no other option. But when you work on real kind of data set, you will always contact to the stakeholder. You can discuss with the concerned engineer and he will properly guide you what's the reason and how to handle it. But here we are not having this much of knowledge, so simply as a data scientist we are dropping these observations because we are not sure reason of failure. Okay. So simply now the question is how you will drop only these observations. We are always applied that we can
have
drop the
to-
column, we can drop the but how you will drop these only these observations. Yes, can anyone write the line of code? Let's see if it is working or not. We want to drop only this, we can't drop one by one. I'm not interested to drop one by one, no. Suppose similar kind of, this is not a very large data set, but in real world scenario you have millions of data, 10 lakh data, and suppose this kind of rows you have some 5,000 rows, so you cannot do this thing manually one by one. Yes, just try the line of codes. So you must mention this particular project if you got the opportunity in any kind of engineering company, interview call from any engineering company. No? You're right, because no one is going to check what amount of uh, observations was there. At least if you know some technical points, technical things, you can explain them and they will realize, yes, you have worked on something. Target drop equal to DF failure equal to no failure index. Yes, correct. So we can apply this particular approach. Target drop equal to DF is equal to DF failure, no failure. Yes, same line of code you can use. So, and again, we have to write the index also. So Muhammad Fakhruddin has written correct. We have to write the index. If you write the index, then we will get all this value in a particular variable, target drop. Same thing. So here, suppose I'm writing this target drop is equal to DF failure. By writing the index, we'll get all the rows name, rows number. So target drop is equal to DF failure. Here failure type equal to no failure dot index. All fine. Let's run it. And when if you print this target drop, these all observations are there, and this is available in this particular one variable. So we can use this. We can use this particular variable. So we can write here df1 is equal to df1 dot drop, and we can pass this particular variable name here. So no need to write the column name, rows name one by one. And next, what I should write here? If I want to drop, let me ask someone.
Axis equal to 0.
X is equal to 0, because if I write x is equal to 1, it will find these things in the column. So I write here x is equal to 0. Simple. Okay. So now this we have dropped. So before dropping, the number of observations was in the df dot shape 10,000, and after dropping df1 dot shape is 9 less than. So 9,999, 9 number of observations was there that we had dropped. The same thing, the same approach we will try for the 0 also. Okay, the same approach we'll try for the 0 also. If there any contradictory, when the one column is saying no, it is no failure, so df no failure equal to 0. Okay, this I'm writing here 0. Oh, I have written O. This is 0. All fine. Then same line of code we'll use. Equal to this. If you want to check no failure head, so all the targets are 0, 0, 0. The same thing will apply. We'll cross check in the failure type if any problem is there or not. No failure type. Yes, there is some problem. This particular column is saying no failure, but some of the some of the observations there is contradictory. In failure type is a random failure. So there is no failure and it is saying random failure. So this is also one problem. If you want, you can check those columns where there is a contradictory. those rows.
We will pass random failures. Failure type equal to random failures.
Yes, yes. So I have to pass here.
No, sir, the other one.
Yes, here, correct. Okay, so these all are the observations. The same thing you will, if you are working on a project, just take the example, and they will ask you to make a PPT. So these two are very important. First, this one, and second, this one. We must paste this particular screenshot in the PPT. Yes, this is the situation we have found. Then what action you have taken? You will write this thing. So the same line of code we can use what you have suggested. Index, target drop. So we can write here some new variable name. Target no failure drop, no problem. Target no failure drop is equal to df failure, df failure.
No, sir, no failure. DF no failure.
Okay, yes, df no failure.
No, not
Why I'm giving such a large target?
no. Target no failure drop equal to DF underscore no failure.
Yes, yes, yes. df no failure, because underscore no failure, and failure type is equal to random failure. Okay, then very easily we can drop it, right? So after finding the index, we have all these values available. If you want to print this also, we'll get this value. Then we can simply we can apply this approach, and we will drop it. So this is also if you want to print. So here only I can write, no problem. These all are the index and simple. Next is the drop it. So df1 dot drop, and we will. So if you want, you can give a new variable name also. In place of df1, we can give df2 also. So df2 equal to df1 dot drop, df2 dot shape. So another 18 columns, 18 rows we have dropped. Now this particular problem we have solved. Next, you can do some kind of EDA of here. What is the reason of failure with respect to different columns? So we don't have large number of columns. So no problem, we can apply the pair plot. If you have large number of columns, then in pair plot you will not find any detailed information, because this size of the all things will be very small. So let's apply here let's do some EDA. Let's do some exploratory data analysis to find the reason of failure. So SNS dot pair plot, df2. If you write here hue equal to one of the target variable, one of the dependent variable, our target multi-class, so it will give us some more information. So let's see. It will take some time. Pair plot. Yes. So I hope many of you have prepared your resume. Now you are applying to different companies also.
So
Yes, no? So please just approach your friends as well as through LinkedIn profile and start applying directly to all those companies, which is just search on the Indeed also. You can find in the Indeed, just search the machine learning topic, or I have mentioned some new designation also, like as data journalist is also in the media industry. They require this kind of post in the publishing media. In the publishing media, this is also one of the very large sector, publishing media, and they require data analysts. One company is there. I have worked on with that company, Quark. Quark is the Indian office is at Mohali. It's a Denver based company. So some 10 years before I was with that company. It is the competitor of Microsoft, specifically in the media industry. So in the newspaper, in this particular social medias, they always required a lots of historical information, historical images. Like suppose you required some original images at that some 50-year-old, some events, something has happened related to that image, that video. So preserving those image, video is really very important, and it required highly sophisticated software to preserve, to maintain the quality, because these are very precious, na? Those images, suppose you have an image of uh, Gandhiji, which is something 100-year-old image, and you want to maintain the quality of that image. Or nowadays, after the invention of lots of editing and all those things, even you can convert black and white to color also, these things. So this basically, this particular company, Quark, is the Denver based company. So they are focusing on this. They are developing different kind of softwares, Quark Express and all those things. They are also using the concept of, they are also looking for many data scientists, data analysts. Okay, so if you, I have uploaded in my WhatsApp, that's thing, na, that different post. So you can search on the Indeed on similar kind of post also. Okay, and if you see the job description, you will find even it is mentioned that data journalist, but they are asking for you have the knowledge of, required knowledge of machine learning, good analytical capacity. Okay, yes, definitely little bit they can ask about the little knowledge of the journalism also. So these all things you can develop, it's not a big deal. So start applying directly also, because this is will be the best approach. Yes, Learnbay will definitely help you finding a good job, but you can get a better job if you will have some good network also, and you will start applying directly. Means directly applying means in a week forward your resume to 200, 300 companies. Okay, but yes, every post, a little customization is required in your resume. You cannot just copy paste. It's not work. So whatever the job description, accordingly, little bit change your description. So 500 times modification will not required. If suppose you are applying 500 companies, but yes, 10 to 15 time, 20 time modification is required. Many places will find almost same job description are there. Okay, no problem. Now here, the interpretation is very important. So let me ask someone who can give some correct interpretation of these images. Yes, Sanket Agarwal. Sanket.
Yes.
Yes, Sanket. So this is our air temperature, and with respect to these are different columns are there. Okay. So just take this example, this one, this particular rotational speed and torque.
Right.
0 is the no failure, 1 is the failure. So what kind of interpretation you can make here?
So if torque is low and the rotation speed is high, there is a chance of failure. Also, if rotation speed is low and torque is high, so there is a failure.
Yes. So extreme, when the rotation speed is extreme, naturally this, what is the relationship between the torque and rotational speed in the general physics terms?
Torque decreases with the speed.
Indirectly proportional.
Is the directly it's not directly proportional, it's the inversely proportional.
Inversely proportional.
So basically torque is the rotational equivalence of linear force. It's a linear force, which is we are applying, suppose you have an object and we are applying a linear force straight line. So just suppose you have a thread and you are rotating in the childs are also playing like that. They just tie one particular ball and they have a 1 meter, 2 meter thread and they rotate it. So basically it's a linear force they are applying, and at the distance they are holding the thread. They did the thread, that particular distance, and the angle between at the rotation, when it's rotation in the circular place, the sine theta of this angle. So this all conclude the torque. So basically the torque, and it is the Newton meter, force into distance, Newton meter, the torque, and it is inversely proportional to our rotational speed. Inversely proportional, torque and rotational is. So here we are finding when the torque is very less. So just take the example, if it is a car and at very high speed, the rotational speed is naturally very high, and suppose there is some mechanism when we are able to control, even the speed is high, and torque should not fall much due to applying some kind of gearbox or anything, whatever component, whatever things you can do. So we can avoid this particular failure, because here we are finding this is the one of the most important factor. Okay, so basically if suppose you will mention this thing, so if the person is the engineer, they can ask what is the relationship between the torque and rotational speeds, what's the torque. So you can say torque is defined as the rotational equivalent of linear force, and it's the straight line about which the object is rotating, is the axis of rotation. Okay, so basically it's a tendency of a force to turn or twist, is the tendency. So we can say torque is nothing but basically it's a force. It's the tendency of a force to turn or twist. That's the torque. And the rotational speed, if I will see here, so we are not going much technical detail, But yes, a little interest is definitely required, whatever domain you are working. If you are working on a medical domain, you will ask, no, I will not use even the medical terms also, because many people I found, they are doing the project on medical domain and they are not able to even pronounce properly the medical terminology. So there is no meaning of doing any kind of project or learning such thing which is you are having no interest. Okay, so don't waste your time in doing any project which you are finding you are no interest. But the hardcore reality, there are lots of vacancies available in medical industry and pharma industry. But the only requirement that you should have some interest in this particular domain. So here also, so rotational speed is also, you should know little bit, the definition is required, nothing else, and little interest. So rotational speed is the, we can say, rotation per minute, and the number of turns.
Number of rotation per minute.
Yes, number of turns also you can write, or number of rotations turns per minute. Okay, so we are finding a direct relationship here. We are finding a direct relationship that if the torque is so basically mathematically, it's both things are inversely related. Because please understand, doing 100 project is of no use if you are not getting any interesting domain knowledge also. This is no use. Okay, because that's the reason a large number of students are not able to crack the interview, because they have just copy paste, or someone has taught them, yes, look, let's do this project, and the same whatever they have done in the housing price prediction, the same thing, copy paste they are doing in the medical also. But this will not work. You have to understand the terminology, because in the interview you can only buy a good time of the interviewer if you can divert their attention towards your interest. This is the technique. If you are good in cricket, just pray that they should ask any question, what's your hobby, what's your favorite game. Then you can create some kind of environment there that they will feel interest asking some new questions related to cricket. You can inform some latest event, latest IPL tournament, just divert their attention. So it will create some kind of empathy. Basically, the interviewers are not looking for what amount of knowledge you have. They are basically, basic intention is, what's your attitude, learning rate, interest. These are the most important factor. If you hire a person, suppose you are the owner of a company, and if you hired even a highly good programmer also, that's no guarantee that this particular programmer will help you in the growth of your company. If his attitude is not good, he is not a good team worker, his learning is not good, he's not interested to learn new topics. Okay, a sportsman can do very well. So if you are a good sportsman, you can be a good programmer also. You can be in a very senior, because you know that if you ask if you have any friend in Europe, Germany, Spain, these places, Switzerland, they will not ask you what's your qualification. They will not ask you what amount of money you are earning, what is the house size. They will ask what sports you play, which game you are interested in. So you will feel that a person who is a good sportsman, I suppose, no problem, I'm not asking that he should be a national level sportsman, but suppose if he's good in cricket, that means he's a good team player, and definitely he's a good programmer also. He's he's taking very important responsibilities in the organization also. Even he will start some business, there also he will success, because he know how to make a good network. Because just playing cricket is very easy, but making a team is difficult. How you will found at the age of some 30-35 year, I hope that most of the students are in this age group, na? How you will find the friends that every Sunday or Saturday let's play cricket, a group of some 20-25 people. So this thing is also some kind of management, na? So in the real world scenario, they will just interested to know what is your learning speed, what kind of person you are. So that's the important thing. So always create some interest in the domain also, whatever project you are doing. So mathematically, torque and rotational speed are inversely correlated. And here we are also finding in this particular, we are finding this one interpretation that failure is at extreme when our torque is high, rotational speed is low, and vice versa. So these one things we have noticed, and we can inform that to the stakeholder. Yes, this is the one observation. Second things you can find here also. So yes, can anyone tell me what other interpretation you are able to make? Yes, Nina Matthew, what other interpretation you are able to make here? Please tell me. Nina Matthew.
The where? Sorry, sir.
Yes, so this interpretation one we have done between this, no problem. And any other? I hope you all are working on the Jupyter notebook. Now you are able to see this thing on your laptop also.
Yes, sir.
Yes, please tell me
Yes.
what other interpretation you are able to do.
The process temperature when it is high. No,
Yes.
actually, when the wear total wear is very high, actually there is a failure.
Total wear.
Tool wear. I mean, not
Tool
total
wear.
wear.
Tool wear is high tool wear. So there is failure with respect to air temperature, whatever the air temperature, process temperature. If the tool wear
Yeah.
is high, there is a failure. Okay. And similarly, also here we are also finding that the torque is very high or torque is very low. That thing.
Yeah.
And there is no direct impact in the tool wear. And the same things, torque is high with respect to air temperature also. So we are not
Which means
finding much.
if the torque is very high or low, there is a failure.
There is a failure. So basically, this is the most important thing: torque and rotational speed, tool wear, and all those things. Tool wear is also having some impact, but process temperature, air temperature has no much impact. And another thing we are
If
finding.
the rotational speed is also high, the temperature goes high.
Yes, rotational speed. When rotational speed is high, temperature, process temperature, air temperature. No. We are not finding such thing. No? Almost all kind of all kind of temperature, this failure is there. Even it is low, high, all those things. Okay.
So rotational speed is high, we have failures, right?
Yes, in this case, when the rotational speed is high, yes, we have calculated now. When the rotational speed is high, there is a failure. When the rotational speed is very low, also there is the failure. With respect to torque, when one is high, another is definitely low. And here also we are finding when rotational speed is high, there are large number of failure.
Yes.
With respect to air temperature. And when it is rotational speed is high, Naturally, if the rotational speed is high, then only the temperature, air temperature, process temperature will increase also. That's the reason. Okay. So now let's do the same thing with respect to type of failures. We can get some idea. Here we will pass the hue equal to failure type. So basically, why we are doing all this exercise? Because suppose you are work on any kind of data set, you must give some time in the EDA, because EDA is very important in the interpretation of this thing, because these many things you will not conclude when you just build the model. So I am again repeating that if you have not worked on the employee iteration, car performance, must work on that particular data set, because you will surprised to see in the employee iteration data set, when you do a proper EDA, that salary is not one of the most important factors. The people are leaving the job. There are many other reasons are there. The management. So if you'll give this advice to the HR department or the concerned management, they can work on it and they can retain the employee. The same things. This is the employee iteration. If you are working on, there is one data set is there. They have worked on. Ola has worked on one problem statement, case study, how to retain the drivers. How to retain the drivers. So they have also found the same thing, that the salary is not the most important factor. They found the most important factor for the driver is the miscommunication, and they have given some kind of in the Bangalore, lots of traffics are there. Because of the traffics, they have the waste of fuels was so high, and they were not able to compensate that thing from the Ola company. And even this, so these are the few reasons was also there. So you can pick any case study, any of the data set. Most important topics are there. Like as one very interesting case study was there. One Chinese university is there. So they had made a case study why the students are not completing the course even after the enrollment in this particular university. So some foreign university, some US based university has done that particular research, that why even the enrollment was very high. Enrollment is very high, but the students are not completing the course after 2 months, 3 months, or in the midway only they have left that course. So that also lots of information they have extracted by doing the EDA. Okay. Yes. So here, what kind of interpretation you can make? Yes, please, anyone tell me. These are the basic failure types: power failure, tool wear failure, overstrain failure, heat dissipation failure. So here we are finding lots of power failure. Power failure means, if you see this particular column, when the rotational speed is high, then only we are finding the power failure. Natural power failure is only possible when your rotational speed is very high. So here we are finding this thing. Rotational speed is high, no matter what other factors are there, power failure is high. This is the power failure. Here also. This observation we can make very easily. And in this case, torque. In torque, yes, we are finding when torque is high, there is failure. But yes, when torque is low also, then there is also a huge failure is there. But here we are not finding, when the rotational speed is low, there is no failure. Very few number of power failures. Although the rotational speed and torque are inversely proportional. When this will be high, definitely rotational speed is high, torque will be low. But these two things we are not able to connect with the power failure. Okay. So the same things we have to do. So please write some kind of interpretation after. working on after analyzing all this particular data set. So that's I'm not doing. So I'm just giving the assignment here, because this is the one of the most important characteristics in a data analyst, data scientist, machine learning engineer, that you should able to read the image. So I request all of you, don't follow any kind of automated tool which give you which generate the image automatically and give the results. It's not a good thing. Just I'm giving a small example of ECG machine also, electrocardiograph machine. Most of the ECG machine having the auto interpretation facility. Most of the ECG machine, but doctors don't rely on it. Doctors don't rely on it. They always see the reports by themselves, ECG different pattern turns, and they correlate this thing with BP, current BP, what is the scenario, their cholesterol level, if recently they have taken any kind of medicine, what is the age, what is the gender, which geographical area this particular person belongs to. Many places you will found in Germany also that many people are very heavyweight, but still they are healthy, they have no any problem. So your weight has no direct relationship with the cardiovascular disease. There is no direct relationship. It's all depends what kind of environment you are, which country you belongs to. These things, lots of other factors are there. So the same thing, although the ECG having auto interpretation facility, you can say since a long time we have the AI is there. AI is doing all those things, but still medical community don't rely on it, because it is a question of on just on the looking at the ECG and its interpretation. They can't recommend you, okay, angioplasty is required. No, lots of other factors they will conclude. The same thing, these all hypes are there, that yes, now AI will come, they will replace all these things, this fellow is not required, that he is not required. No, your real intelligence no one can replace. These all AI and all those things will save the time. No, there is no question. Suppose, assume if this ECG machine has no interpretation facility, so naturally the doctor will not find any clue, any hint, any support. But here they are finding the support with the interpretation, and they are analyzing the things by reconfirming all those things. So the medicine they are writing on the basis of their analysis, not just on the basis of this interpretation. The same thing, a decision, a company will not going to invest. Just suppose your stock price prediction, AI is saying yes, this particular stock will next few months it is going to be the one of the best performer. Just on the basis of, a person will not invest unless until a experienced person will also interpret this thing, who has already applied, who has already invested his money, who had taken the risk. If you have already taken the risk, then only you can give a correct advice. So these all things will be definitely continue. So no need to worry. Even though Chat GPT will come 3, 4, 5 version, AI will. These all YouTubers are making to increase their TRP. They are doing that nothing. They are just two fellow will sit with mic. They will speak. Okay, in the near future this will be happen. This will be happen. No one can replace your intelligence. Especially in medical community, doctors never use artificial intelligence. Never use this all machine learning for the prediction of a disease, what medicine I should get. They always apply their experience, their teamwork. Okay. So assignment here is the, please make the interpretation based on visualization. as above, right? So this thing please do. Now the next thing is, and suppose you want to create some kind of, because suppose you want to create a large image of this also, you can do also. Just select a these two columns in the scatter plot, and you can create a larger image of this particular column also. Just take the example I have just taken here, df100 equal to df1. What is this, df1 or df2? df2. df100 equal to df2. I'm just taking these two particular column. One is the rotational speed, comma, it's not only rotational speed, there's something, name is some different, rotational speed underscore rpm, and torque nm. Suppose we want to draw a large image, many times it's required if you are preparing a presentation also. So better to, this will not look very good because all the images not able to give you some interpretation, some good interpretation. So just you can select any two of the columns. Suppose I just created df100 equal to this, no problem. And we can just create a data set, or we can just use this particular df100 and we can plot a graph, right? Or otherwise you can write like that also. So sms dot scatter plot data is equal to, either you can take df1 or df2, df2 or df10 also, 100 also, df2 and suppose you want to know that in the case of failure, just you want to know in the case of failure. So failure means you have to pass here df2 target, better to pass here target. We want to just see the failure target, when target equal to 1, different kind of images equal to 1, and then you can pass x equal to rotational speed, and we can pass here y equal to this torque, right? And hue equal to failure type. Anything, whatever you want. Hue equal to, suppose I'm writing target, so that is also fine. But target we cannot write because target we have already selected one. So I'm just pass here failure type. What are the different failure? If it is a failure type. And before that you can write the plt dot figure fixed size, plt dot fixed size 10:10. Okay, so some bigger image we can find, we can make better interpretation by looking at this. So what are the different failures points are there? Here it was not very informative, no? So this thing also we can do. We can get the idea with the rotational speed and torque. So power failure, most of the places we are finding in this situation. Power failure, tool wear failure, overextend failure, heat dissipation failure. So you can make a good interpretation by plotting a large image. So please do this thing also. Okay. Now interpretation is very important. EDA is very, very important. So please, why I am asking, because this is a very small data set, but in reality, suppose you got the chance to work on the oil and gas industry, there are some 400, some 80 or 100 number of different sensors or columns or even more you will found. So you will realize that since last 5-6 days, you are only working on the ADA, only working on the ADA. Even many interesting thing you will see that people who are working on a particular, one of my student who is from Canada, she is doing MBA from one university, I think Toronto University. Okay, she is also a student of Learnbay. She worked with me on one project that was the Twitter stock price prediction, but the university asked her just not to confine on the time series forecasting, just not find the price of the Twitter, okay, this month price will be this, just make a complete analysis that when the Twitter was this particular Elon Musk, there was some when the Elon Musk is announced, yes, we will buy Twitter. Later on, some controversy was there. Some senior position has resigned. So this entire episode, you have to cover the entire episode with respect to the price. This was the project in the Toronto University, and the student, a group of students, they were working, and I also helped them. So you cannot work on a data set just like as, yes, I know random forest, I know this, my job is finished. No, you can connect the social media information also. You can connect with these things of the recent news. That kind of support basically company is looking for. They are not just asking you, okay, this is the data set, just clean it and do the prediction. What they will do of that prediction, no use. No matter if you have built a model, it is giving 99% accuracy, there is no use of those model if the whatever you have developed, it is of no it is not creating any kind of impact in the decision. So learning is something, but in the real world scenario, how it is useful, it's all depends on which company you are working for, which country this particular company belongs to. There's lot of factors. So that's why they are looking for managerial skill also along with the data scientist skill. A manager can understand very well if I will launch a product. So what amount of revenue we can generate. A sales manager knows this thing very well. So I'm not asking you should be a sales manager, but you have the managerial skill. Then only when you build a model, the usefulness of the model can be determined. That thing is required. So here you have to make all those things interpretation. Now next things we can do is the correlation matrix. We can find the correlation between the columns. So simple, it's very easy. I think all you have worked on it. So I'm just starting because we have very few number of columns, very few number of columns. So this is the df2 dot head. If you will see, we have hardly only this much number of columns are there. So let's find the correlation between the columns. So if you write simply sns dot heatmap, df2 dot cor annotation equal to true. So this is all the formalities we are doing, because in 5-6 number of columns, what kind of interpretation you can do. So no problem, we are finding a high correlation between these two columns, air temperature and process temperature, rotational speed and torque. Naturally it is very highly correlated, but I'm not taking any kind of dropping these columns, because we are only having very few number of columns, and we have done the EDA and all the interpretation. We found, yes, naturally the air temperature and process temperature are highly connected. This torque and this is the negative relationship. One is increasing, another one is decreasing. This is the inversely relationship. This is the direct proportional. This is the inversely proportional. These things also we are finding here. Okay. But we have very few number of columns, so that's why I am not dropping any of these columns. So you can try some kind of more EDA on the basis of this. So let me write here only after this. Because I always prefer to give more and more time on EDA and the evaluation matrix, because applying a model is not a big deal. Importing something, fit it, predict it, anyone can do. But after the prediction, whatever result you are getting, how do you interpret that result? How do you apply the regularization approach, optimization approach? These actually companies are in the interview, they will ask lots of questions related to the optimization technique, regularization technique. They will ask some kind of real world scenario also. Just suppose you are working on a, or whatever project you have mentioned, they will ask, okay, suppose you are having large number of data. So what amount of data you will pick for the training? You have some 50 lakhs observations. So what amount of data you will pick for the training? This kind of question they will ask. Similarly, they will ask, suppose you are not finding a appropriate result. So what is the meaning of in the classification problem? You're not finding appropriate result. How will explain it? And what action you will take next to improve the accuracy or some kind of performance? So basically, they are interested to know if really you have some kind of experience or not. So no matter if we don't have any, assume we don't have any industry experience, but if you will work on different kind of complicated data set, then definitely you will gather some kind of experience. And after giving some interviews, you will be expert how to manage this situation well. So here, please do some do plot some pie plot. What are the basic things we know that can par, count, etc. based on different kind of failures and other components and other input variables. Because if you have this kind of habit, then only you can do a real justification when you work on some kind of data set, just like oil and gas industry, or something technical data set, or some kind of accident. Like is in one, there is very nice data is the reason of accident, road accident. The government has, some universities have worked on that particular project also, how to minimize the road accident. So with the help of data science, because we have a large number of data available, that this particular junction, there is the road accident in this particular time between these two vehicles, the speed of the vehicle is there, the driver gender characteristics, everything is there. So on the basis of that, the transport departments can make some kind of changes in their rules, their road design, traffic control. This is also one of the nice project. It's available on the one of the US website also. There lots of information regarding the accidents. So the prediction is also very useful when you work on the very cold climate area. Like suppose they are giving one, you are making some kind of, so must work on the case study, not just on the data set. If you are working on a case study, so some European country, German, their temperature is -20. Still the railway tracks and many the things freeze because of the low temperature. So they can predict in advance that after 2 hours, this particular, at this particular area, the temperature will be this. So they can take appropriate action, they can divert the train, all those things on the basis of your prediction, machine learning prediction only. Okay, so next to what things are required. Yes, so one thing is there, we have one column is there, that is the type column. So here we can do something on the basis of type column. What is the different kind of failure? If it is a medium quality, high quality, low quality, so percentage of failure with respect to the quality of the component, that thing we can do here. Okay, percentage of failure based on quality of the component, low, medium, high. We have 3 quality of components here, low, medium, high. So on this basis also we can do some kind of EDA. So let's take low quality. Low quality component equal to df2, type equal to L, so if you take the print of this, so low quality, oh no, so here we have just consider this particular one quality. So you all are enjoying this session or not? Please tell me, are you feeling bored or it's informative?
Informative.
Yes,
Informative.
Okay, thank you. Because I am not just covering only the basic things, yet fit it, predict it, your job is finished. Because I am just trying to give little technical things also, and the basic fundamental how you should crack an interview, what kind of approach is required, that thing also I'm discussing. So let's see, the low quality is your resume play very important role. That's I'm reminding again. It is not just a piece of paper. Basically behind the resume there is a human being, there is a family, many things depend. So your resume should be very good, and the interviewer has hardly 4 to 5 seconds of time to decide whether this resume in the filtration, for the interview call filtration, whether they will assign a opportunity for the interview or not. They just give 4 to 5 seconds of time on the resume, because for a single vacancy, on an average, they have some 250 to 400 number of resumes. But again, the interesting thing is there. Suppose if you have prepared for some competitive examination, IIT, JEE, so don't create any kind of fear with the number of applicants. Number of applicants can be 10 lakh. Number of applicants can be 10 lakh. But a person whose preparation is good, he knows very well. Even the teacher is well aware that this person will get definitely a good rank below 1000, 2000, 5000, this kind of. So out of this 10 lakh people who do appear in the IIT examination, you will found 70 to 80%. I think not it's very high number, no problem, but at least 60% students are of no use. They have not prepared at all. They are just doing the formality. Yes, I should appear for the examination. So balance is the 4 lakh. Out of this 4 lakhs, they are again 3 or 4 categories you can easily divide. So basic competition is hardly with 2 lakh students. Even this is, you cannot say competition. Basic means real, due to some luck factor, you can say few people are not selected or whatever the reason. So just take the 20% people are only are real serious candidates. So even the same thing, if you are finding 250 resumes, you are finding in for the one post, So here also you can consider something like as 20% or even lesser. So hardly for one post, 30 to 40 resumes will be there. But the most important things, your resume should be filtered. And then your domain knowledge, all these things will start come. So no need to worry about the how many people are doing this particular course. Most of the people are just doing, after joining the course, they realize, okay, although I have joined this course, but this is not my cup of tea. This is really very tough. Because at the beginning, they just heard the name of AI. When they join, they realize, no, the salesman has told this thing is not required, but we have to be work hard. So don't fear looking at the crowd. Yes, so for the target, this is the low quality, that's no fine, all fine. So let's see what is the case in the case of medium quality. So low quality is all fine. So let's calculate the medium quality. Medium M quality equal to df2 type equal to 1. If you write here this thing, if you print this thing, M quality target value counts. So basically what we are doing, we are making the analysis that what is the impact of buying a high price component, low price component, medium price component, what amount of failure is there. That thing we are interested to see. Okay. So normalize equal to true. Oh. Why this is value counts? Okay, so in this case we are finding 97 and 2%, 2.64. Basically here we can check 2.64, 3.86 is the difference between the low and high, and similar things we can write here, copy paste high quality also. So here I'm just writing high. So if the quality is high, it is 2%, 3.8, 2.64. So there is no much difference you can find here in this case, 2% and 2.64%, and there is definitely some 1% differences here in the low quality. That's the reason they have used a large number of component of low price also. So we cannot use the word low quality. Actually, it is a low price. Okay? Low price. So they have, that's why they have used. So this kind of interpretation also you can give. So the low price component having high failure, but this you cannot say the difference is very high. So this kind of interpretation we can make, although the low price component has failure amount 3.86 with respect to medium 2.64 and high price is 2.00, but the difference is high, but you cannot say it's very high. But the difference is it's not very high. So it may be, I don't know what's the interpretation we are doing, but whatever, as a data scientist, we can make it. But yes, if it is, you are talking about some very highly this kind of lift and anything, so you cannot take even a 1% of chance, because these things lift airlines, the accident are very, very less, very low as compared to airlines. If you make the comparison with the road transport or even the railways, the accident is very, very less in airlines, very less. But in case of accident, it is really very fatal. Similarly, in the case of lift also, you will not hardly will found that lift having any kind of accident. What if any accident happen in the lift? Suppose there is a free fall of the lift, so it will be fatal. So in the reality, companies, if you are living in a high-rise building, these persons are not taking this thing very seriously. But even a 1% is very high amount for the lift on airlines. But if you are talking about some other common scooter or bike or something basic cars, so this is not a very high value. Depends on what is the price of these components. Now here missing the handling the outliers is although we can find the outliers, but handling the outliers is not recommended, because definitely the torque is high, RPM is high, we are finding the failure on that scenario only. When it is very high, then only we are finding the failure. If you will handle the outlier here, suppose some outlier are there, so dropping outlier is not at all advisable. But assume you are capping the outlier, that also it's not a good advice, because companies are interested to know what is the reason of failure. So handling outlier is good, but don't apply blindly unless until you have a solid understanding of the domain. Okay, although we will found here there are lots of outlier. Just check finding.
Sir, one question I have.
Yes, please.
So we did the correlation analysis. So in the correlation analysis, torque and rotational speed were inversely like had high negative correlation.
Yes.
Right. So are we supposed to generally, whenever there was a high positive correlation or negative, we end up removing one of the columns?
Yes, correct.
So here, would we be removing one of them?
Here you can remove, but the question is, we have, suppose you are not in your data set, there are two columns having high multicollinearity. Just take the example. This column, just take any one, this one and this one having high multicollinearity, and you have not dropped any one of them. Then what happened? What are the drawbacks? What are the drawbacks of keeping multicollinear column in the data set, high multicollinear columns in the data set? What are the drawbacks? Drawback number one, computational time.
Predictions can be inaccurate, right?
No, prediction having no problem. Prediction having no problem. Keeping a high multicollinearity column also, if you are keeping, the prediction, you will not find much difference in the accuracy.
Then, sir, my question is, why were we told to remove?
Yes, I'm coming to that point.
Yeah.
The first reason is the computational time. The second reason is sometimes you will find the overfitting problem. Our model will work very fine in the training data set, but not in the testing data set. The third problem will be feature importance. If you are selecting the best feature, just in this case only, just take the example. Assume we have some five number of columns are there, 1 2 3 4 5 6 5 columns, just take the example, 5 columns are there, and we are finding the best performing 3 columns, 3 features. Okay. Best performing 3 features. Suppose rotational speed is the very most important feature, it is the significance is very high. Just take the example, its significance is very high. Then what happen when we work on that, when you select the best 3 column na, so it will consider rotational speed naturally, and it is, if it is having high significance, this will also, it will select torque also. And then third will, so priority wise, this is the top, second, third, fourth, like that only. So although these two are highly correlated, machine is not learning any new things by keeping these 2 new columns to both the columns, but still it will give the importance, most important features as these 2 along with. This is the problem in the feature importance. So these all problems arises when we are working on some little large data set. Here also you can drop, this is not a issue, you can drop, but we have very few number of columns, so that's why I have not dropped. Suppose you will drop these 2 now, whatever left with us, column number 1, column number 2, 3 column only we left. Okay, so that's why I'm not dropping, because although if I keep a benchmark of 0.9, this is lesser than 0.9, that's why I'm not dropping. This is also one of the reasons, but there is no hardcore rule that you should not drop. You can drop and you can build the model.
Okay,
But usually
I can drop and I can check as well, right?
Yes,
Like
yes, right. But usually when we have large number of columns, now suppose in place of just 5 columns, if I had some 20-30 columns also, then definitely I will drop. But here we have very few number of columns, that's why I have not dropped.
Okay, got it, sir.
Because computational time will not big issue, we have only 5-6 columns. Overfitting can be possible, no problem. Feature importance, yes, but only 5-6 columns are there, that's why we are not finding much.
Sir, overfitting, how it is related to multicollinearity?
Overfitting is always now, but you suppose you are finding a good overfitting means a good performance in training.
Like the variance is more here and bias is less, right, sir?
Yes, so training bias is low bias,
Variance, high variance,
and high variance is the overfitting, correct.
but how it is related to like multicollinear columns or features?
Because machine is getting at the time of training period na, suppose you are having, you are getting the help of this column also in the training, so naturally your training will be good when there are many people are there who will support you. That means this person, this is a teacher which is solving some of your problem, this is also a teacher which is solving the same mathematics problem, no problem, but anyhow you will get some benefit now keeping these 2 column in the training, in the prediction. So your training will be much better if you keep the duplicate kind of columns, duplicate rows, your training will be better. But at the time of testing, the very new data will come, so usually at that time you will not find that benefit. You have
Like, sir,
developed
if we have in the training data set, if we have that 2 variables also,
yes,
then what will be the problem?
overfitting problem, it can arise sometime na, because suppose you have some duplicate column or duplicate rows also, that's I'm using the same word, either you have a duplicate columns, duplicate, it is one kind of duplicate column na, whatever information this person will give, the same information he is also having. Machine is not learning very new thing, because suppose this is very high, correlation is very high, so at the time of training it will provide more help, it will help to understand the pattern in more serious, just like as overfitting means what, these all are the observations, just take the example. So this will be create like that pattern, it is reading the pattern like that. This is the overfitting. More you will train it. Suppose you have 100 number of questions, and I ask you to learn this 100 questions 4 times, 5 times, 10 times, and you will mug like that. Na? Question number 2, answer is C. Question number 9, you will remember even like that also. Okay, just like suppose I'm just giving a very funny example. It's really a reality also. Suppose you are playing a CD or pen drive in your car, and you are listening those songs since many times. Many times you have listened that particular pen drive song. So once the first song will complete, na, you will automatically in your brain will come, okay, now the next song this will come. So your brain has synchronized with the music. Your brain has synchronized with the music. If the one song will finish of any movie song, Hindi song, what the next song, without looking at the dashboard, without looking at the music player, your brain will say next, this will be the next song. Although you have thousands of songs in your pen drive, the same thing will be there because you have repeated the same things many times. It is understood like this pattern. But when a new pen drive will place in your car, you cannot predict the next song. That's the same thing. So overfitting is because of the duplicacy of these columns. This column is also helping for the prediction, same thing. So that's the reason when we have multi-collinearity in our data set, sometimes it creates the overfitting, but it's not guaranteed. Sometimes it creates the overfitting problem. Is it clear?
Even if the rotational speed and torque both are important, but since they are sharing same number of information, so we have to drop one.
Yes, definitely we can, because of this reason. Even if you suppose it is a regression problem, if you plot a OLS, na, if you draw a OLS, so you will find the p value will be definitely high for any of one of the column. Means we are not able to reject the null hypothesis. This thing. So you can build the model dropping column also. It's not a.
So it's so can we take it as a mandatory or it's not mandatory?
No, it's mandatory. Because
mandatory,
this most of the time we don't have only 5-6 number of columns in our data set. Most of the time we have large number of columns. Okay, so wherever you're finding any kind of multi-collinearity, better to drop it.
And also we have been told that don't go by this approach, means just look target column, and wherever there is same number, then we are having multi-collinearity and then drop. So is it
no. It is like that. It's not the same number. If you are because multi-collinearity you can only found in the independent variable. Okay, this is the one thing.
Independent variables, right? Yeah.
Independent. So multi-collinearity only will found in the independent variable. So here there is no question why I should suppose you want to drop. There is no any problem. No one will ask you why you have dropped. You can drop. Okay. Now the another thing is there that you are asking. Now look at the target variable. So this is like that. Suppose you have taken this thing as a, just take the here example also. This is a target variable. So in this target variable, the impact of temperature is 0.83. This much is the impact significant degree of significance of this particular first column in the prediction. The second column 0.636. The third minus 0.044. Torque is highly.
Yes, right.
And this tool wear is also okay. No problem. Now, assume you have a data set and you are finding one particular column value is 0.9. All others are, and all other values are some like that only. 0.08, 0.02, 0.1 also, no problem. 0.002. So this particular column is dictating. This part, that is means basically it is some kind of, you can say, target variable basically. That's why it is dictating. So no one will give you such kind of easy assignment or in the real world scenario when one column is dictating and you are building the model. Be natural. your model accuracy will be amazing. Amazing accuracy will found, because this column is only this one particular input variable is enough to predict all the things. But this is the wrong approach. You should drop this column and build the model. Naturally, we will not get a good accuracy. It's very difficult. Keeping this column, your accuracy is 99%, 97% performance. After dropping this column, it will automatically drop to something 40 or 45%.
Dropping, or we can scale every
This particular,
variables.
yes, because now we have left with only other columns, which is not highly significant. But this is the real machine learning, to drop this column and build the model, then apply some kind of optimization of approach, regularization approach, hyperparameter tuning, or feature engineering, and try to improve this 45%, whatever you're getting, you are fine, improve it even up to 70% or 75%, then also it will be considered as a good model. It's not bad, because it was so difficult and so really highly complicated. So this is the thing. But what happened many times, if the person is not well aware of all these things, so they will ask, no, your accuracy is not good. But in real interview, you will not find such kind of scenario. They will happy to know that you have applied this particular approach, that one column was highly dictating. That means you are not able to understand, but actually it is because of some lack of domain knowledge. This column is the target variable. Somehow it's very close to target variable. That's why we are not able to this part single column is dictating the prediction. Okay, this is the thing. Is it clear?
Yes, sir. Yes.
So more challenges you will face during the solving a model, more learning will be there. So no one will be asked what amount of accuracy you are finding. You cannot print and paste on your resume that all the models. One of my students has asked me in the same kind of session, sir, I am finding almost all my data set, whatever the trainer has given me, whatever classes I have attended, mostly I am finding my accuracy is 90%, 92%, 95%. So in the real world scenario, for this kind of job only, I will get such a handsome salary, because easily I am getting very good accuracy. So first I realized that perhaps he is working on very easy kind of data set, all balanced data set. But he told, no, I am working on highly imbalanced data set also. Then I asked him, okay, just show me your codes. So what he was doing, I don't know from where he has learned. He was balancing that. He was applying the balancing approach, but he was balancing the entire data set. Naturally, if you balance the entire data set, your accuracy will be very good, because you have balanced your training data set also and testing data set also. So naturally, your accuracy will be good. But in the real world scenario, you will not find a balanced data set. Your data set will be highly imbalanced. Means out of 1000 number of patients, if you are checking your model, 950 will be healthy people and 50 will be diseased people. 5% is the one class. And that scenario, whatever model you have trained in very pamper mannered, balanced, you are finding here 90%, and here you will get some accuracy, something like a 60%. So if you have committed your stakeholder, I have developed a model, and as promised, the model accuracy is 90%, 95%, just release the payment. But once you install your model, they will immediately revert back and they will say, no, we are not getting 90% accuracy, we are finding 60% accuracy. Because they are using your model in the real world environment. So never create this kind of mistake. Whenever you are working, if your balancing is required, only and only balance the training data set, never ever the testing data set. Never ever the testing data set. So these things are also required at the time of interview. They expect that you should have the correct knowledge of this thing. So same thing, suppose you find the outlier, so sns.boxplot. We have lots of outlier, but we will not handle the outlier. We will leave it. because these outliers are very important for the prediction. And actually the company is looking for those data where very high torque is there, high rotational speed is there, these all things. And so look, here is the outlier, but you cannot handle. The same thing you will find in the rotational speed also. There will be outlier. We are not going to drop it also, and even we are not interested to cap it also. So no dropping, no capping. Lots of outliers are there. Okay, but we will not handle the outliers. Leave it. Now the next one thing is there. This particular column is the object variable. Low, medium, high is there. So one approach, either you can apply some kind of label encoding. So what approach I should follow here?
We can use map.
Mapping function, because it's the ordinal. It's the ordinal data. So for the ordinal data, better to apply the mapping approach, because we can assign manually the value, but in the label encoding it will follow the dictionary approach. So df2 type equal to df2 type dot map. Let's create a dictionary. So L is 0, medium is, we can pass L is 0, medium as 1, and simple we can pass high as 2. Okay, so 1 0 1 2 it will assign. Now if you want, you can check the df2 type.
Sir, I have one more question here.
Yes, please.
Sir, here this data set is quite imbalanced. So shouldn't we be balancing it?
Yes, very good question. But always remember this fact also. If anywhere people are saying we should balance immediately, no. Okay, first balancing is imbalanced data is really a challenge. It's a problem. But balancing a data is also not a only approach. This should be the last approach. Imbalanced data is a problem. First of all, if you are working on real world scenario, you can demand more data. You can ask the client, look, I got your data set, but I'm finding one particular class is very few in number. So it's very difficult to build a model. Very difficult. I'm finding one particular class, one disease patient's numbers are so less. How one machine will learn what is the pattern of this disease patient. So please give us more data. More data means more actual data we required. If any case we are not getting this kind of support, we have only limited data, no problem. First of all, either you can apply some kind of feature engineering approach. If you have the domain knowledge, you can create some new column. We can extract some mathematical formula. You can create some column. This is called the feature engineering. Don't get confused with the word that feature engineering means scaling, finding outlier, label encoding. These are called the pre-processing. Feature engineering. Engineering means creating something new. Creation of a new column basically is called the feature engineering. So you can apply this thing also. which help you in the prediction. Second thing, suppose you are not able even doing this thing also, no problem. Many algorithms most of the time work fine even our data set is highly imbalanced. Just one example, if you will using the logistic regression, one parameter is there, weight balance. Okay, if you will make it true, or if you opt this thing, weight balance, even though your data set is highly imbalanced, there is a good chance you can get a better result. This is the first approach. Second approach, many tree-based algorithms, bagging approach, boosting approach, even work fine on imbalanced data set. Okay, these things. And in worst scenario, after doing all the exercise, suppose you are not finding the good result, then balance the data set. Then balance the data set. Then we have various options are there. Overfitting approach, smooth is there. Borderline smooth is there. Edasine is there. There are all different mathematics calculations are there. Okay, underfitting is also there. So they can also ask, you should be aware in which scenario we should use the undersampling. Sorry, not underfitting, undersampling, oversampling. In which scenario we should apply the undersampling approach, which scenario we should apply the oversampling approach. So these all things we can do. But don't take the first step as balance the data, then build the model. No, it's not a correct approach. Because in the real world scenario, we will find the imbalanced data set only, where they will use our model. Okay, so it's better to train the model in imbalanced data set environment. In the worst scenario, if it is not working, then balance only the training data set and build the model. But this should not be the very first step. This should be the later on, when you are finding your model is your different algorithms you have tried and it is not working fine. Then at least after balancing, you can realize, look, after balancing, I found, yes, accuracy or our performance has improved. Otherwise, you will not even able to make the comparison that without balancing, even after lots of efforts, we were not able to. And as a student's point of view, if you will try to solve the problem without balancing, you will learn a lot of things. That the same question I told, the student was asking, I'm getting a so nice result. That's the reason. He was balancing the data at the very beginning, all the data set. It is very easy job for the trainer. Being a trainer, I can do these things. I will balance the entire data set at the very beginning. And in 2-hour session, student will be happy. Yes, I will solved. Now our accuracy is 99%. So a nice training it was. But in reality, I seized the opportunity of new learning. And in the interview, this will definitely pay, because you have not got the opportunity to learn. Okay. So never ever balance the data set at the beginning. Do it later on if required, but only balance the training data set. Is it clear?
Yes, sir. But sir, I have one more question. So you are saying balance it later on, right? So
Yes.
like for decision tree and all. So even if in case of decision tree, I kind of I do it, the proportion in which it takes the samples would still be what I'm meant to say is, if the proportion is 9:1, like, we have, so
Okay.
if you see, so those trees will also have the same proportion, like the stratified sampling, wherein they keep the proportion to be same, right? So in that
Correct.
case, the bias, so it would be still be biased towards one side, right?
Yes, yes.
So like my question, so what I wanted to check is, sir, are you saying that first you do it
Without balancing, correct.
without balancing, and then when you mentioned if required, right? So what, like, if required is like, should we check accuracy and all and then go ahead with balancing?
Correct,
Is that
correct.
what you are?
Yes, suppose you are finding if the pattern is easy, then it's not necessary that just take the example. Suppose in one data set you are working and you are finding it's 95% and 5%. Okay, in one data set. And another data set, again, you are finding 95% and 5%. But the pattern of this particular are so easy in this particular data set that even without balancing, you are finding almost a good result in the recall. Just take the example for class 0 and class 1. Here you are finding 90 and 80. It may be possible. But this pattern was so difficult that in the recall, you are finding it is 90 and it is 30. Okay. Even both, this is also imbalanced, this is also imbalanced. But this pattern was easy. Machine has learned even very few number of observations. It was easy. So this kind of problem also you can face. Okay. So just don't balance it immediately. Even in this scenario, we are not finding good results. We'll apply different algorithms. First of all, we'll do the hyperparameter tuning. Then also, if it not work, then the one approach is there. Isolation forest approach is there. That also will apply. Anyhow, we will learn something. And balancing is not always a very good approach, because anyhow you are just finding a synthetic data or the duplicate data. So that doesn't mean if you have just solved 10 mathematics question, and and you are not happy, I will ask you, okay, no problem, I will make a photocopy of these questions, I will give you 1,000 questions. That doesn't mean you will be more confident in this particular mathematics. It is only possible if you have varieties of questions. So this is mostly we are doing in balancing. If the data set is very less, so there is no guarantee after balancing you will get a good result. The other things will be only help you. The selection of right parameter tuning, right kind of algorithms, these things will be more useful. In the real world scenario, balancing is not just a one method that we should immediately apply and solve the problem. In reality, it will not give a very good result most of the time, unless until you are not tried some other, because it is always better, na? You have applied the different algorithms on highly imbalanced data set and you are finding, okay, good. Out of these 10 algorithms, these 2 algorithms is working fine, even the data set is imbalanced. So at least you got this idea. You have applied the hyperparameter tuning also of this. Now you have selected these final 2 algorithms. And last stage, you are doing the balancing. So after balancing, apply that 2 performer, that 2 particular algorithms. So you can justify, yes, overall performance is good. Right?
Yes, sir. Sir, so would you be showing like this example without balancing and with balancing, or how it would be?
Yeah, we will work here also. First of all, we will calculate without balancing, then with different algorithms will apply, then we will balance the data set on the training data set, no problem. And then we can see immediately you can find the effect, which 2 algorithms is working fine on the imbalanced data. They will definitely give some better result, but there is no guarantee that you will find a drastic change. If you are balancing the entire data set, there will be excellent outcome, but it's all a eyewash. But if you are balancing only the training data set, a little improvement you will find in the performance, but this is the reality and this is the real achievement. Okay, so we will follow the correct path. We will only balance the training data set, never ever the entire data set.
Yes.
Okay, right. So no problem. Tomorrow we'll continue from here, and tomorrow I will conclude this particular project. And if required, I will give some assignment or some other data set also. You can work on it. Okay.
So in this data set, we can see like balancing and other optimization techniques.
Yes. But the hyperparameter tuning, I can give the line of code. But many times, if you apply this grid search CV, it will take something 40 minutes, 50 minutes. So anyhow, I will give the line of code. You can apply. Okay, and we will follow all the steps. Don't worry.
Okay.
All line of codes I will.
And sir, one more thing, like in classification problems, is it
Yes.
required to do data scaling? Feature
Yes,
scaling?
it's mandatory. Because if you are using a classification and you are using the tree-based, this distance-based algorithm, like
Distance based, yeah.
logistic sometimes logistic regression also work very fine in the classification. You are using KNN, SVM,
Yeah.
neural network, even neural network, this scaling is mandatory.
No, sir. In distance case, it is okay because we have to calculate the distance. So for a large, it will take
Yes.
calculation time will be more if
Yes.
we will not do the scaling. But instead of if we are not taking any distance algorithm,
For
then
the tree-based algorithm, scaling is not required, outlier treatment is not required. You can try this thing. Just pick a
Yes.
data set, scale it, and use the random forest or decision tree. See what accuracy you are getting. No matter even it is a regression problem, and without scaling, apply the same decision tree and random forest. You will find exact same result. So there is no benefit of scaling a data set if you are using the tree-based algorithm. But usually we
for regression also, sir.
Yes, regression, classification, any case, no problem. But most of the time, what we do scale it because we are not sure now which algorithm will work fine.
Yes.
So
Yes.
that's why we do. Otherwise, if you ask so there is no requirement of scaling in the case of tree-based algorithms. But we scale it because many algorithms required, PCA required scaling. PCA will not give you good result if the data is not scaled. That's the reason.
Okay, sir.
Okay. No problem. So let's meet tomorrow and we'll continue this particular project. Okay. Thank you very much.
Thank you, sir.